We are on video 5, guys. And for today's video, I decided to just try to rock out all of chapter 5. I feel very confident that if you guys watch this video a couple times per section and use the worksheets that I have provided for you on Classroom, and I'll even kind of show you them as I go, the ones you should be able to look at, that the skills in chapter 5, the rest of them, will be easy enough that if you make that effort, you'll be able to handle them. Like, for example, 5.2 homework practice. This is from section 2 that I said I might skip or whatever, but I made an executive decision to kind of go over this right in a row. We already did 5.3 though, so we'll do 5.2, then we'll do 5.4, 5, 6, and 7, all in this video, and it shouldn't take that long, but you have to take the initiative to watch it a couple times every time you switch sections. Anyways, proofs. Proofs are one of those things that's frustrating because it's one of those things where it tells you something to look at. You know it's probably true, but you still have to prove it true anyway. And so especially if you're one that's good enough at some of these problems that you like to skip steps, it's going to be frustrating because you have to now go forward and explain each step. Even though you may or may not have done that step, you have to be able to tell me and others why it happens and how it's true. So for example, this is the first problem on your homework practice sheet, okay, which is usually the third sheet that I download for you on each section. It has this given thing. Whenever you're doing proofs, they always have to say things that are given, okay? It's given that two intersecting lines, obviously these two lines intersect, okay? It's given to you that the measure of angle 1, this guy here, is 6x plus 45. Okay, it's also given to you that the measure of angle 3 is 9x plus 15. So we have these two angles, which, if you remember from one of the other videos and or both the other videos recently from chapter 5, 1 and 3 are what we call vertical angles. So these should be congruent, right? So you should be able to take these, set them equal to each other, and solve for x, and get what they said we're trying to prove. Hopefully we'll get x equals 10. So, some of the explanation is just you kind of teaching this stuff. So, it says angle 1 and angle 3 are vertical angles, okay? So, they are congruent, and so, like I said, you would put them equal to each other, okay? That's by the definition of what vertical angles means. Solving this from previous lessons, you should know that subtracting 6x from both sides, okay, and 15 from both sides, okay, from each side, that gives us 30 equals 3x. Okay, we call that the subtraction property of equality. To know that you can subtract those things from what we've done with equations, that's technically called the subtraction property of equality. If we subtract them from both sides, that keeps them equal, in other words. Then you may remember we would divide by 3, and we would get x equals 10. When we divided by 3 here, lo and behold, big surprise, that's called the division property of equality. Meaning as long as we divide on each side, we're still keeping it equal. Okay, then we would get x equals 10, and voila, this is a paragraph style of explaining what happens for us to get x equals 10 when these two lines intersect. Now, on the skills practice worksheet, I jump to number 2. The skills practice just gives you a table format of how to do the exact same thing. So I'm going to be an old man getting down on my knees here. They have a given statement and what we have to prove using some vocabulary and symbols that I'll refresh your memory on. This is the picture that they give you for number 2. Given that the lines A and B, lines by the way are always noted by small lowercase letters. You should never use a capital A and a capital B because those denote points on a graph. Okay, they are parallel. Those two lines are parallel is what they're saying. This was A and B, these two lines I probably should have marked. Okay, let me just check. As a matter of fact, I want to get this perfectly right for you so that you see that the lines that these are is this one was line A, this one is line B, and this one should be C, yes. Okay. So this is a table format that we've got these two parallel lines, A and B, cut by line C, a transversal. Okay, remember these were called transversals when they cut through two lines. Okay, angle 1 is a right angle. Okay, so they told us angle 1 is a right angle, which means that it's how many degrees? You should know that right angles are 90 degrees, right? So we want to prove that B, and this funky symbol here means perpendicular. We're trying to prove that B is perpendicular to line C. And I even wrote that. That means perpendicular. So this is a table format. Your sheet, your skills practice sheet, tells you these statements and it asks for your reasons why. And the first one is A, this funky sign means parallel. It looks like kind of like an 11, but it means parallel. A is parallel to B, cut by a transversal C, and that the measure of angle 1 is 90 degrees. Why does that sound familiar? Because that line right there, I wrote in red the things that you should have filled in, is that's given to us. Okay? For the first thing we do on proofs, you write what's given to us. Then it says, or we should say, that measure of angle 1 is equal to measure of angle 5. How do we know that? Because of the corresponding angle stuff we've talked about, where 1 and 5 are in corresponding spots on those, right? Angle 1 in this section is just like angle 5 in this section. So since those guys are equal, because of corresponding angles, I can take measure of angle 5 and know since those are equal, I can say that because angle 1 is 90, that angle 5 must also be 90. And since they are both 90, angle 1 and angle 5, that helps us prove that B is perpendicular to C. This is 90 degrees, so when B and C meet, we should know that that's 90 degrees, and that makes them perpendicular. Just two ways of doing a proof like 5-2. Okay, there are several other examples that you can kind of talk your way through on the other ones. If it helps to watch this a couple times, that's 5-2. We rock that out, we jump to 5-4. Now, in 5-4, we start talking about something, well, we start talking about polygons in 5-4. And polygons is a real easy concept where you take this formula and all you do with this formula is just plug and chug. You know me and I use that term all the time as plug and chug. I'll erase the rest of this in a second. I'll just do this. If you have a polygon is just any shape. Okay, we just talked about how triangles, the angles in a triangle add up to 180 degrees. That's something you should kind of know. If it's a four-sided figure, okay, those angles add up to 360 degrees. Both of those come from this formula with a capital S. They say in here is n minus 2, and we just multiply whatever that is times 180 degrees. Now, what in the world is this n minus 2 from? The n is the number of sides. Okay, so if this was a four-sided figure like we had here, it would just be 4 minus 2 times 180. And what's 4 minus 2? 2 times 180, and that equals 360. That's what this formula right here tells us to do. So if I have some cockamamie figure that does something like this, I would say, okay, here's a side, 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 and there's a side. Okay? 7 sides to that figure. So to find that guy, I would take 7 minus 2 times 180. So that's 5 times 180. And 5 times 180, I have a hostess over here that's going to give me this. But I know it's going to end in 0.
900.
Even. Yeah. That's 900. And that would be 900 degrees inside a 7-sided figure. Okay? All you're doing is counting the sides, taking 2 away from it, and multiplying it by 180. That's why I feel like I had the confidence in saying, okay, 5-4, not a problem. 5.5 starts talking about something called the Pythagorean theorem. Okay, let me go ahead and erase this. Pythagorean theorem always has to do with triangles. Okay, and the more specific thing with Pythagorean theorem is not only does it always have to do with triangles, it has to always deal with right triangles. There has to be a spot in the triangle that's a right angle. Has to be true whenever we're doing the Pythagorean. Has that fun name because there was a guy a long time ago named Pythagoras, and so we have the Pythagorean theorem. And that theorem is a squared plus b squared equals c squared. Now, what does that mean? Any of the shorter two sides of this triangle, either one of them, we can label as A or B. Those can be interchangeable as long as they're the shorter two sides of the triangle. The hypotenuse, this is called a hypotenuse, it is the longest side of the triangle. That is where C has to be. And so on your sheets again, that I will do with you and look at what you have together, you will do some problems where we use this Pythagorean theorem. The first one, if you're looking at your reteach sheet, okay, it gives us a triangle, and I'm just going to kind of erase values as we do each one. It gives us a triangle where the first side, this is 4, and this is 5, and we don't know this guy. So we make him the C. Okay, we can label this guy A, we can label this guy B, or you could have done it, this is B, this is A, it does not matter. So when I fill it into this formula, I would say 4 squared plus 5 squared equals the C squared. All I did was plug and chug. Plug the 4 in, plug the 5 in, and we're going to try to find C. That means 4 squared is 16, 5 squared is 25, that's going to equal my C squared. Well, what's 16 plus 25? That's 41. That is equal to C squared though. And if we want just C, we would have to take the square root of this number. And if you're using your calculators, that's going to be C, which is what we want. If you use your calculators, you can find out what the square root of 41 is. It's what, my dear hostess? Actually,
6.40.
Yep, this is approximately 6.4. That gives you your exact value or rounded off value of what square root of 41 is. Since 41 is not a perfect square, you could actually leave it as square root of 41 at times, and that would be okay. Okay, that's the first one given to you on your paper that you should be able to follow along and do if you care enough to look at that. Okay, so pause your video if you still need time on this, or ready to move on to the second one on this sheet. Okay, they give you, and this is kind of going to be flipped around, but they give you your C, and they give you a 9 at the bottom, and they give you a 5 on the side. Their triangle is flipped this way, but it shouldn't be that hard to figure out here that this could be my A, and this could be my B. We don't know our C again. So I would say 5 squared, this side, plus 9 squared, this side, equals my C squared. Okay? 5 squared, hopefully you know, is 25. 9 squared, you should know, is 81. That is equal to C squared, not C. When I add those guys together, I get 106 equals C squared. So to get regular C, I would have to take the square root of 106. Okay, and that equals C. And what's the square root of 106?
10.30. That's rounded. But
It rounds to about 10.3. C is 10.3. Okay. That is all you would really need to write if you used a calculator, or you could again write square root of 106 because 106 is not a perfect square. If it was a perfect square, then we could write what the total answer is, and you'll see why on some of these possibly. Okay, the last one, I'm going to go ahead and rewrite this triangle because it's like upside down and backwards and everything else. But you will see that there's still a right angle in it right here. And they give you that this is 15. And they give you that this is 25. Real tricky. And that this is A. So if this is the right angle, that means this is the longest side. So that's really our C. And since that's A, we can make this our B. And so if I fill this in, I don't know my A, so this is still A squared. I know my B, that's 15 squared. And I know my C is 25 squared. And then I plug and chug and do this away. A squared stays A squared for now. 15 squared, I believe, is 225, right?
Yeah.
And 25 squared is 625, right?
Yeah.
Okay, now, just like when we did our proofs, we use the subtraction property of equality. I can subtract 225 from both sides and get A squared equals 400.
Yeah.
Now 400 is a perfect square. So here's where you're going to see that regular A would have to be the square root of 400. And the square root of 400 is simply 20. 20 times 20 is 400. So that's a perfect square. Alright? Knocking out the regular Pythagorean theorem section. The rest of these things in chapter 5, and one of the main reasons why I said that we can knock this whole thing out, is the last two sections have to do with the Pythagorean theorem. So we're going to continue to just use the Pythagorean theorem to do the other problems in the next two sections, or three sections, but I think it's two. So, if I'm looking at the homework practice now, homework practice on lesson 6. We're now on 5.6, homework practice. And yes, I abbreviated homework to home. Okay, 5.6, homework practice. The first thing they give you is this upside down triangle-ish looking figure, but it's more of a real life situation because they tell you this is 6, and they tell you this is 8, and these are miles. And we don't know this distance, and since it's a distance, they use the letter D to try to confuse you. Because they've got this figure here that they drew, and they've got a little tugboat over here that they drew, and I use my awesome drawing skills to show the boat. We want to know how to get from here to here in a straight line, not in a triangular shape. So again, I can make this my A, I can make this my B. If this is a right angle like we should know, then this could actually be a C value. So that I can still go 6 squared plus 8 squared equals, and you could say C or D squared. 6 squared is 36, 8 squared is 64, and that's what C squared would be. And this is nice because this will equal 100. That's C squared. So to find regular old C, we would have to take the square root of 100. And the square root of 100 is 10. So this distance here, if this was 6 up and this was 8 over, that distance here would have to be 10. Not 100, like some of you might have stopped there. You still have to take the square root of that number and get to where that distance is 10. Okay? And maybe, just maybe if it helps me to redraw the triangle, we knew this was 6, we knew this was 8, and we just found out that that guy was 10. Okay? I want to do number 2, and we'll stop with that one. Again, look at these more than just once on the video, and this will definitely help you through these, because these are more real life situations. We have this, says this is a wire that goes this like this. And we want to know how do you get from this point on the wire to a distance here which they say, and my drawing's kind of sloppy, but sorry. Okay, they say that distance is 2, not x, feet. And they say that distance here, to make it real difficult on you, they make it a decimal, is 1.5 feet. And if we want to know this distance here, this is basically a C. They label it on this guy a W just to confuse you again, right? Okay, but using the same theorem, I should be able to take 1.5 and square it. I should be able to add that to 2 and square it. That should equal my C squared, or the W like they use this time. Now, 1.5 squared is 2.25. Okay, 2 squared you should hopefully know is 4. And that's what C squared is. If I add those guys together, I get 6.25. That equals C squared. We want to know what C is. So we would have to take the square root of 6.25 to get what regular old C would be.
2.5.
Okay, and the square root of 6.25 is 2.5 if you use your handy dandy calculator. So again, if I was looking at this triangle that we made that looks something like this, we knew this was 1.5, we knew this was 2, we just figured out that this longest length would be 2.5 to get from there to there. Okay, that is chapter 5, lesson 6 in a quick nutshell. Again, watch that a couple times so that you know how to use the Pythagorean theorem to do this and find the distances between 2 points. The last thing in chapter 5 is extremely similar, and I'm really glad that I brought this grid board home because it's asking you, what if I was trying to find the distance between 2 points on a graph? Well, guess what? Let me try to make this pretty straight. Better. Okay. Right, and say I make a triangle in here. Maybe I'll make the exact ones that they do again. Okay, if I look at your lesson 7, I pulled the reteach worksheet this time. And their first point is at 1, 1. Okay, that point they even label is at 1, 1. Okay, then they give you another point that's at 6, 3. 4, 5, 6. 1, 2, 3. Okay, and then where they draw a line, okay, from there to there. And we want to know, well, what in the world is that distance? Okay, how do we know how to get there and find out how the distance is? Well, guess what? We just did a couple sections on Pythagorean theorem. So if I know that this went down this many and over this many, I can figure out that I just went over 1, 2, 3, 4, 5. I went over 5, and I went up 2 to get from this point to this point. Now this kind of looks like a triangle, I hope, right? Okay, so this could be my A, this could be my B, and this could be my C. And I can say if A is 5, I would say 5 squared. If B is 2, I can say 2 squared. And that equals my C squared, 5 squared. Let me go back to my black so it shows up a little bit better. 5 squared, you should hopefully know, is 25. 2 squared is 4. That's C squared. 25 plus 4 is not going to be a nice perfect square. Okay, that equals C squared. You would have to take the square root of 29 to get just regular old C, which is
5.4 rounded.
it rounds off to about 5.4. Okay, or you could just put the square root of 29 for your answer if you didn't have a calculator, and that would be fine. Okay, I'm going to do let's just do number 2 on that same page. Getting rid of number 1 if you didn't finish number 1. Guess what? By the powers of technology, you can just rewind it, pause it, do whatever, and you'd still have number 1 on the board for you to look at. Okay? So if I still have this guy, my coordinate plane, and if I'm looking at number 2, it has a point at -2, 1. And the other point for it is way over at 4, 3. 1, 2, 3, 4, 1, 2, 3. That's point 4, 3. And they want to know this distance. Okay, so we take our wonderful minds that be, we figure out that this is actually a triangle that I can use. That I know that I went from here, I went over 1, 2, 3, 4, 5, 6. I went over 6. And again, I went up 2. So we've got an A, we've got a B, and we're trying to find that distance, which we can label as a C. So that means I can say if that's A, that's 6 squared. If that's my B, that's 2 squared. And that's going to equal my C squared. 6 squared is 36. 2 squared is 4. That's equal to C squared. 36 plus 4 is 40, which is equal to C squared. Okay, 40 is not a perfect square. Okay, so if we take the square root of 40, we're going to get our regular old C, which the square root of 40 is
About 6.3.
6.3. If I round it off, our C is actually equal to 6.3. Okay. If you didn't have a calculator, since 40 is not a perfect square, you could write it that way. There is one other way you can write it, but it's hard to explain on a video. But if you have the square root of 40, you can get 40 by, see if I can see it.
You break it off.
I can break it into the square root of 20 times 2, but that's not a perfect square either.
No.
So,
Like, so it would be 6, because 6 times 6 is 36, and then 7, because 7 times 7 is 49.
see, that's one that's hard to explain on a video. I'm going to leave it at this for you guys because it's going to be plenty to have this answer, square root of 40, or when you take the square root of 40, you get 6.3. Those are perfectly 2 ways to write that answer, both correct. There is a third way, but again, hopefully one of those 2 ways works. The third way I think is probably more complicated, so I think it would just confuse more of you to learn the third way than it would be to stick with these 2 ways that they are right now. Believe it or not, that's all of Chapter 5 that we hadn't covered at this point. Okay, again, take advantage of your technology. Pause it when you can. Rewatch a section when you can, because all of this, especially sections 5, 6, and 7, are almost the exact same thing, just using them in different ways. Okay, 5.1 we spent a lot of time on, and 5.3 we spent quite a bit of time on. 5.2 and 5.4, 5, 6, and 7 I just did in a nutshell, and hopefully with you looking at the sheets that I provided and or getting with me through Remind or Google Classroom or however in the world you can email me or whatever. Remember, my email address is pretty easy to remember. It's R Freeman, and then it's going to be at what everybody else's is, and that's Lakeville Schools. .org. That might be a good way to get a hold of me also. But Remind, email, probably the best too. So that's it for today, guys. That's 5 videos. That's all of Chapter 5, so we can knock out Chapter 6 coming up real soon. Thanks. Be safe. Be healthy.